Hello everyone, welcome back. In this part, we'll be focusing on building the movie detail screen. Along the way, we're going to fetch the data for a movie, then display pieces of information in a list. Finally, we'll learn how to display a Safari View controller in SwiftUI to show the YouTube video using UI View Controller representable. So, let's open Xcode and start coding. We're going to continue from part 2, where we have successfully built the movie list screen. Let me open the preview file to show you the movie detail screen. First, we'll focus on building the navigation title and the movie banner image. Let's create a new file named moviedetailview.swift in the views folder. Declare a movie ID instance property inside the class. We'll pass the ID of the selected movie when instantiating this view. Next, to handle loading data from the TMDb API, we need to create an observable object. Create a new Swift file named movie_detail_state. Declare the class that implements to observable object protocol. Declare the movie service API client as a private constant. For the published properties, we declare movie is loading an error. Then we create an initializer with movie service as the parameter. Then we assign the movie store singleton as the default value. We set it to the movie service instant property. Next, declare the load movie method. It accepts a single ID integer as the parameter. First, we set the movie to nil and set its loading to false to reset the state. Then, we invoke fetch movie, passing the ID of the movie. Inside the closure, make sure to declare self as weak to avoid memory leak when referencing self. Then, set its loading to false and use a switch statement on the result enum. In case of success, we retrieve and assign the associated value to movie property. Then, for failure case, assign the associated value to the error property. Navigate back to the movie detail view. Then, declare the movie detail state property using observe object property wrapper. Assign the movie detail state instance as the default value. Also, we need to pass the movie ID in the movie detail view initializer located at the bottom of the file. Let's implement the body next. We use cstack as the container view. Then we declare the loading view passing its loading state and optional error property. With this, the activity indicator view will be shown when the movie is being fetched. In the retry closure, we just invoke the load movie, passing the movie ID to reload the data. Before we declare the list, let's set the navigation bar title first. The value is the title of the movie. As it can be empty when fetching is still in progress, we need to provide an empty string as the fallback value. Make sure to add on appear modifier where we load the movie and passing the ID to the state when the screen appears. Also, to enable navigation in the live preview, we need to wrap the movie detail view in the preview class at the bottom. For the list, we create a new view called movie detailed list view. Declare a movie constant as a single property. In the body, we use list view as the container. At the top of the list, we have the banner image of the movie. Let's create a new component for this, as it has its own state to handle the loading of the image from the network. Declare a new view named movie detail image. To handle loading the image, we declare the image loader observe object as the property, and also the image URL to load. In the body, we declare a Z-stack. At the bottom, we use a rectangle as the placeholder when fetching the movie. We set the fill color to gray and opacity to 0.3 using the modifier. On top of that, we check if the image has been downloaded. Then we declare the image, passing the image data and set it to resizable. Then using the aspect ratio modifier at CStack, we set the aspect ratio to 16:9 and content mode as width. At last, we use the onAppear modifier to fetch the image, passing the image URL. Let's declare this into the top of the movie detail list view and see the results with the live preview. Looks like we forgot to add the movie detail list view inside the movie detail view. So let's add it at the top. So let's build and run it again. Yeah, looks good. Let's remove the extra padding on both horizontal sides by setting the list row insets and pass edge insets top, leading, bottom, trailing to 0. Moving on to the next part, we're going to build the section containing the information of the movie: genre, release, year, runtime, overview, and rating. As the movie model currently doesn't have genre-related property, we need to create it first. Let's take a look at the JSON response. It's actually an array of JSON objects containing the ID and name. Navigate to the movie.swift file, declare the genres property in the movie. The type is an array of movie genre. At the bottom of the file, declare a new struct named movie genre and conforms to decodable protocol. Next, declare the single property name. We don't need to declare ID as the property. Go back to the movie struct and declare a computed property called genre text. In the implementation, we just get the first index from the genres array and use the name property. Next, we create a computed property to show the rating stars, named rating text. First, we cast the vote average double property to an integer. This will remove the fraction and run down the number to simplify the logic to display the stars, as we are going to use a star emoji to show the rating. By using a half close range operator that starts from 0 to the rating integer, we use a reduce method to add and accumulate the value with stars emoji. At last, we return the result. Besides the stars count, will display the score of the rating in terms of 1 to 10. Declare the score text property. Using guard statement, we check the count of rating text is greater than 0. If yes, we just use string interpolation on the rating text and suffix it with /10. The next one is the text for the year. To show the year, we need to create a new date formatter and set the format to YYY. With the formatter, we can use a guard statement to invoke the get date from the release dates text. And then use the year date formatter to get the formatted string from the date. The next one is the text for duration. We can use the runtime property for this. It is a representation of total running seconds for the movie. To format it to show into a format like 1 hour 30 minutes, we can use that component formatter. Let's declare the duration formatter, set the unit style to full, and allow units to hours and minutes. At last, we can use the formatter and pass the runtime second of the movie multiplied by 60, because the formatter is expecting a unit of minutes. Let's go back to the movie detail list view. Below the movie detail image, declare a h tag. Inside, we declare the text containing genre text, text containing hardcoded .string as a separator, the text for movie, year, and the text for movie duration. Moving on to the next row, let's declare the movie overview text. Then, we declare an h tag. If movie rating text is not empty, we display the stars rating text and set the foreground color to yellow. Then, at last, we display the score text. Let's use a divider below to add a horizontal line for clearer visual separation between sections. In the next section, we'll show the credits of the movie, cast, directors, producers, and screenwriters. We need to add the credits property to the movie model. Let's take a look at the JSON response. The movie JSON has credits field containing JSON of crews and cast. For the cast, we only need the name property, while for the crews, we need the name and the job. With job, we can filter the crews based on the producer, director, and screenwriters. Let's navigate back to movie.swift file. Scroll to the bottom and add a new struct named movie credit. Next, declare a movie cast struct. Add ID, character, and name as the property. Then, declare movie crew with ID, job, and name as the properties. Go back to the movie credit and declare cast property with movie cast array as the type. Then, crew property with movie crew array as the type. With this in place, we can declare the credits property, which is using movie credit as the type. We'll set this as optional as this property is not returned when we fetch the movie list API. Next, we declare the cast and crew's computed property. With this, we can retrieve the cast and crew from the credits property. To get the directors, producers, and screenwriters, we declare the computed properties. Inside, we just filter the crew array based on the job string, director, producer, or story. Now, let's go back to the movie detail view and build the credits section. To stack the cast and crew horizontally, we can use HStack. Set the alignment as top and spacing to 4. Then, we declare a VStack with alignment of leading and spacing of 4. To stack the starring cast, at the top, we show the title text and set the font as headline. Then using for each, we pass the cast of the movie. In this case, we only want to display the first 9 casts. So we can use the prefix method in the array. In the closure, we just display the name text of the cast. Oh, looks like the compiler is complaining, as for each needs movie cast to conform to identifiable protocol. Let's add this to the struct. We add a frame modifier passing 0 as minimum width and infinity as the maximum width. Then we add a spacer. We'll use this so the VStack can have equal spacing with the other VStack containing the crews that we'll create next. Next, we declare the VStack for the crews data. As crews can be empty and nil, we'll use conditional before declaring the VStack. First, we check if movie director's count is greater than 0. Then, we declare the director text and using for each passing the array of directors. In this case, we only want to show the maximum of 2 crews. Let's also add the same conditional check for the movie cast, as it is possible for the cast to be empty. Then, let's move this into the HStack to show it besides the cast. Make sure to set the font as headline for the heading text. Let's do the same approach for producers and writers. Also, add some padding in the producer and screenwriter text to add some vertical spacing. That's it for the crew sections. Don't forget to add the divider at the bottom. Next, let's move on to create the trailer section. Whenever the user taps on one of the trailer, we'll present a model sheet showing the SafariViewController containing the YouTube page for playing the video. Let's create the movie video struct to represent the trailer. Navigate to the movie instance and declare the struct at the bottom of the file. Let's take a look at the JSON response for the videos. We'll be needing ID, key, name, and site. Then, we declare the movie video response struct with results property containing array of movie videos to match the JSON response hierarchy. At last, we declare a computed optional property called YouTube URL. As video can come from a different site, in our app we only want to show the trailers from YouTube. So, using guard statement, we check if the site equals to YouTube. Then, we construct the URL by prefixing it with https youtube.com/watch and adding additional URL param passing the key property. Back to the movie body, we declare a videos property with type of optional movie video response. Then, at last, we declare a YouTube trailers computed property, which returns an array of movie videos with a valid YouTube URL. Let's go back to the movie detail view below the last divider. We check if the movie's YouTube trailers array is not empty. If exists, we show the trailer text, set the font as subheadline we use for each, and pass the trailers. In the closure, we use a button, and let's leave the action closure empty for now. For the view inside the button, we declare an hashtag containing the text of the trailer, name, spacer, and image with SF icon with the name of play.circle.fill. Then we set the foreground color to system blue. Next, we need to create a view to host the SafariViewController. Create a new file named SafariView in UIKit views folder. Import Safari services and SwiftUI at the top of the file. To host a view controller in SwiftUI view, we can use the provided UIViewController representable protocol. Declare SafariView and make it conform to UIViewController representable. We need to implement two required methods. Let's declare one instance property named URL. The first required method is makeUIViewController, which expects us to return a UIViewController. In this case, we replace it with SafariViewController. In the implementation, we can just initialize it, pass the URL from the instance property, and return it. Let's leave the other method implementation as empty. Go back to movie detail view, then declare a state property to store the trailer when the user selects from the list. Then, in the button action closure, we just need to assign the selected trailer to the property. To present the model sheet, we just need to add sheet modifier at the bottom. Pass the selected trailer state as the binding item. Then, in the closure, we just initialize and return SafariView, passing the trailer from YouTube URL. Let's try and run from the live preview to make sure everything works. Scroll to the bottom and tap one of the trailer. Nice! The Safari VC is presented perfectly. There is one little bug though, where when we dismiss the model sheet, the image banner will blank out of nowhere. I don't really know why this happened. Maybe it's a bug from SwiftUI. But I have found the solution. We just need to declare observe object for the image loader in the movie detail list view and pass it to the movie detail image. So let's do this. Try to run again. Looks like all is good. Finally, we need to add navigation link on the movie list screen so it can navigate to the movie detail screen whenever the user taps on the movie from the carousel in the list. Let's add this to the movie backdrop carousel and movie coaster carousel views. We just need to wrap the view in navigation link, then pass the movie detail view in the initializer. Also, we need to set the button style as plain button style. Otherwise, the image will be overlaid by a blue background. Let's try and run the app to test the navigation. Just select a movie from the list and voila, we successfully navigate to the movie detail screen. That's it for part 3 of this tutorial series. In summary, we have successfully built the movie detail view to show pieces of information for a movie. Then we fetch a single movie data from TMDb API, Finally, we learn on how to use a UI view controller representable to present the SF Safari View Controller using a model sheet presentation. In the next final part of the tutorial, we'll be building the search screen. So, until the next one, see ya guys. Bye.